Hi everyone. Today in this video we're going to talk about the second order derivative. After you have found the first derivative, normally we use a symbol f prime x or dy dx. We're going to differentiate again, which is finding the second order derivative. Normally we will use the symbol f double prime x or d2y dx, so depends on the questions. So here I have some example to show you what is the means by the second derivative. So find the second derivative of px. I'm given this function the name px. So when we want to find the first order first derivative, I'm going to use the symbol p prime x. So to differentiate the px with respect to x, we're going to apply the power rule, which is I'm going to take the 4 multiplied by negative 2, and then the power of 4 minus 1, you will get power of 3 plus 27 of x squared. How do you get 27 x squared? You are going to take the 3 multiply by 9, you get 27, and the power of 3 minus 1, you get x squared. And for this term, negative 5x squared, how are you going to differentiate it? You're going to move the 2 to the front and multiply by negative 5, you got negative 10. And the power of 2 minus 1, you get x power of 1. And for the last term, which is a constant, differentiate a constant, you get 0. Alright, so after that, to find the second derivative, I'm going to differentiate the first derivative again. Alright, so symbol that I use is a p prime prime x. So the same method we are going to apply. Negative 8 multiplied by 3, you get negative 24 x squared. Alright, the power 3 minus 1, you get 2. And after that, 27 multiplied by 2, 2 you move to the front, multiply by 27, you get 54. And the power of 2 minus 1, you get power of 1. Negative 10x, which is x here, you get a power of 1. 1 multiplied by negative 10, you get negative 10. And x power of 1 minus 1, which is x power of 0, which is equivalent to 1. Okay, so you have this term as a negative 10. And this is your final answer, okay, for your second derivative. So now we proceed to the next example. If y equals to 5x cubed plus 2x minus 1 over x, find d2y dx2. See or not? Sometime, okay, with a function given the name as a y, then you're going to write the second derivative as your d2y dx2. Okay, so here, before I start, I will rewrite my question into this form first. 5x cubed plus 2x minus x power of negative 1. So in this form, it's easier for me to see when I want to apply, to find the, to differentiate it. So here, when you want to find the second derivative, you have to go through the first derivative, that is your dy dx. Okay, so dy dx, how do you find the dy dx? You will take the 3, move to the front, multiply by 5, you get 15. And then you have your power minus 1, you get power of 2 plus 2. Alright, and then negative 1, move to the front, multiply by negative 1, you get positive 1. And then the power of negative 1, you get negative 2. Alright, because negative 1 minus 1, you get negative 2. And I'm going to rewrite this as a 15x squared plus 2 plus 1 over x squared. Alright, so now if you want to find the second derivative, you're going to write second derivative as a d2y dx2. So differentiate this function, this dy dx again, you will have your 30x. And differentiate a constant, of course you get 0. And differentiate the x power of negative 2, you got negative 2x. And then the power negative 2 here, minus 1, you get negative 3. Alright, so simplify it, you get your 30x and minus 2 over x cubed. Simplified it. This is your answer as your d2y dx2. Okay, So here I have 4 more examples to find the second derivative. For the question A is a polynomial. It's very simple, very easy to differentiate a polynomial. Let's look at a dy dx. All right, to find the dy dx, I have my 20 x power of 4. 5 move to the front, multiply by 4, you get 20. And then the power of 5, you minus 1, you get 4. Plus 2 move over to the front, you get a 2. And then you got a x power of 1 because the 2 here minus 1, you get 1. And plus for the third term, differentiate the third term 8x, differentiate 8x with respect to x, you got 8. All right, and the constant you get 0. So we proceed to the d2y dx2 because the question asks for the second derivative. Okay, so differentiate again. 20 multiplied by 4, you got 80 x power of 3 plus 2. Okay, differentiate constant here again, you get 0. For the question B, okay, we have a y equals to x squared multiplied by 1 minus 3x. Before I start to differentiate, I would like to expand them first. Easy for me to apply the differentiation. So x squared multiplied by 1, I have x squared minus x squared multiplied by 3x, you get a 3x cubed. So now you back to the polynomial, okay, back to the expanded form. Then you can differentiate easily. Differentiate x squared, you get 2x minus 9x squared. All right. And then the question asking for second derivative. So you differentiate again. You get the differentiate 2x, you got 2. Differentiate the negative 9x squared, you got a negative 18x. All right. So this is your d2y dx2. Let's look at the question C. Question C, given the y equals to 1 over x plus 2. Okay, y equals to 1 over x plus 2. So here I'm using the chain rule. Before I start to differentiate, I will rewrite the 1 over x plus 2 as a x plus 2 power of negative 1. And then I apply the chain rule, which is I differentiate outer function first. I got my negative. This is the inner function, x plus 2 inner function. Okay, the outer function is a u, as if that this is a u represented by u power of negative 1. So I'll try to differentiate u power of negative 1. How am I going to differentiate u power of negative 1 with respect to u? You're going to take the negative 1, move to the front, you get negative 1, and then this remain as a u, but actually the u is your x plus 2, and then the power of u we're going to minus 1, you get negative 2, and then multiply by differentiate inner function. Okay, differentiate x plus 2, you get 1. All right, so simplified it, you will have your negative 1 over x plus 2 squared. Okay, so this is your dy dx. So now we proceed to the d2y dx2. d2y dx2, I will still refer to this form. Easy for me to differentiate. Again, actually this is your negative x plus 2 power of negative 2. Okay, so how are you going to differentiate it? You will move the negative 2 to the front. You multiply by negative 1, you got 2. All right, you got 2. And then power of negative 2 minus 1, you get negative 3. And this is the inner function, x plus 2. Just copy it down without changing anything. And multiply by, now it's a turn to differentiate in inner function. That is your x plus 2. Differentiate x plus 2, you get 1 again. So simplify it, you will have 2 over x plus 2 power of 3. Okay, power of 3. So this is your d2y dx2. Let's look at the last question, which is your D. Question D, y equals to 4 over 3 minus 2x power of 5. So again, before I start to differentiate, I will rewrite this function as a 4, 3 minus 2x power of negative 5. So here, again, I apply the chain rule. Apply the chain rule means that you will fix this as your inner function, 3 minus 2x as your inner function, and my outer function is a 4, as if that this is a u power of negative 5. So close this up, okay? Just ignore this. I'm going to differentiate 4 something power of negative 5. So how are you going to differentiate it? You're going to take the negative 5, move to the front, combine with the 4, multiply with the 4, you got negative 20. Negative 20, and then what is inside the bracket, just leave it first. Okay, just focus on the power. You get negative 5 minus 1, you get negative 6. And this is an inner function. Just copy it down without changing anything. And then after that, multiply by, now is a turn for you to differentiate the inner function. Differentiate 3 minus 2x with respect to x, you get negative 2. Alright, you get negative 2. Put a bracket for it. And after that, you are going to simplify it. Negative 20 multiplied by negative 2, you got positive 40 over 3 minus 2x power of 6. Because of the power negative means that it will be put at the down, okay, as a denominator. Alright, so this is just a dy dx. So now we're going to proceed for the 2y dx2. Okay, so for the d2y dx2, again, I rewrite this in this form. Easy for me to see. Negative 6. 3 minus 2x power of negative 6. So now, our outer function is 40 u power of negative 6. And inner function is a 3 minus 2x. So first of all, 3 minus 2x, just ignore first. We will focus on this 40 and the power of negative 6. So how are you going to differentiate 40 u power of negative 6 with respect to u? We're going to bring this negative 6, multiply by 40, you will get negative 240. And then what is inside the bracket is not important for this moment. You just focus on the power, minus 1, you get negative 7. Alright, and then the inner function, just copy it down in the bracket. And now multiply by, you now need to differentiate 3 minus 2x. This is, which is your inner function. You differentiate the 3 minus 2x, you get negative 2. So now we are going to simplify. We have done the differentiation actually. Now we just need to simplify it. Negative 240 multiplied by 2, you get a positive 480. Alright, 480 over 3 minus 2x power of 7. Okay, so this is your d2y dx. Alright, thank you for watching.